Well, I'll start with a question if we're not having anyone come up yet. No, go. Please.
I'm Alan Bubis, Imperial College London. Thank you very much indeed for those very interesting presentations and to give us lots to think about. Could I ask the last speaker, Cronin, a question? I think what that last study you presented, to me, illustrated something that nutritional epidemiologists have been aware of for some time, but we largely ignore, is the psychological component. It seemed to me that by simply intervening and discussing with the individuals, changing their pattern, it had an impact. And this has been demonstrated in numerous studies that simply by showing an interest in the individual, there is a desire to respond and please them. And I think that that's a dimension we haven't heard much about today, is behavioral aspects of nutrition, and where does the new science, the new biology in that area take us in terms of the world, the brave new world of nutrition and the new technologies?
Yep, I tend to agree with you, and I'm sure Lorraine will also have thoughts on that. Is this on? Yeah, it's on. Okay, sorry. I think you're right. Like, just the fact that they had to come in, everybody had to give bloods, everybody had to do that, the DNA, everybody had to report their diet on a regular basis. So even that alone improves your outcomes. I did it myself for 2 years, measured my diet using MyFitnessPal, and it was very effective. So it was very good. So it's kind of depressing to think after all this fancy genetics and phenotypic work, actually at the end of the day, just getting people to write down their diet is probably an important part of the study. But what do you think?
Yeah, I guess the key point is that the people who were in the control group they didn't know that they weren't getting personalised information. They got reports that looked exactly the same as people who got getting the personalised information. So they did feel that they were in a study, and that they thought that because they were taking their buccal swab and doing their, that they were getting the information. And it's the same, and we could apply the same for the 3 levels as well, that people actually done everything even though they didn't get the information back. So I think it's the actual importance of doing it what they had a big impact on the individuals as well.
I thought that was fascinating what you presented, Greg, with just the fact that they were 0.9 chance of being not the placebo was hugely influential on the way they went about the study, and it's fascinating that the psychological aspect of these things is so important.
So if you're able to maintain blinding, which you may not be able to do, the randomization to randomization design may be helpful to you in teasing apart the expectancy effects that you're discussing, or the placebo effects, from the treatment effect per se of the treatment that you're interested in. And it might be worse than you say, so I showed the balanced placebo design to try and get at this issue that you raise. And in fact, the idea being if you give someone a placebo and you tell them that they're getting a placebo, there shouldn't be an effect, no effect. And in fact, sometimes there is an effect. So that's bad if you're trying to get a good treatment effect. If you are trying to ethically treat a condition that doesn't seem to respond to other effective treatments, like chronic pain, then telling someone that they're receiving a placebo and seeing a response, which you might see, can actually be an ethical way to treat a condition that might not otherwise be treated. So I know that's a little outside the scope of nutrition epidemiology. There may be other ways in which this problem that you rightly raise may be used for therapeutic purposes.
But I think you're right. I think companies are getting that point, and I think that's why the Apple Watch and other apps that help you manage your own health are actually becoming popular, because at the end of the day, whether it's an app helping you to manage your diet, or whether it's a person, as long as it works for you and you see benefits, I think people are starting to understand that.
Question?
Yeah, Josh Anthony, Campbell Soup Company. Thank you all for your very informative talks. I have 2 questions as it relates to that last study, the Food for Me study. Because I've always been a little bit surprised that there weren't differences between just the diet-based personalization, the phenotype and the genotype, the addition of the phenotyping and the genotyping. So my first question is it possible that part of that effect is because those, a lot of measures looked at like energy expenditure or health eating index, the diet part of personalization is enough to explain that. So you're getting enough information there to make a personalized adjustment. My other question kind of relates to the other, some of the other aspects that were talked about, which is really looking more at a population base versus N of 1. Is anything known about the study participants with respect to their goals or their unique needs, where when we're looking at groupings of them, diet, phenotype, genotype, you're not seeing differences. But on an individual basis, there's certain things there that may be important to them. MTHFR SNP and somebody that has high blood pressure, and so they're adjusting the riboflavin intake, or looking to become, pregnant, so they're adjusting folate intake, as an example.
Yeah, I think that it was looked at, actually. There were groups of people segmented out by specific genotypes, and even psychology and their desires, I think, was also studied, and their, and I think you're right. Like, it may, on the grand scheme of the 2,000 or so people, just see one kind of not very, exciting effect, but maybe within that there were groups that were hugely responding, huge groups that were the other way, and eventually end up kind of evening out in the mass of the data. There was a huge amount of papers that came out of Food for Me, huge amount of study into different groups of people based on genotype. And I think at the end, what Professor Gibney, who is the principal investigator, started thinking about more was sub-cohorts of people, rather than personalized, one-to-one, like for every single individual nutrition. It was more about, well, can you cohort people into similar groups who can be thank you. I could have done that if you just okay. Making subgroups of people, and however they're formed, whether it's through genetics or through psychology, I think is a fascinating area of health research to be in the future. Yeah.
Jim?
Hi, I'm Jim Hill from the University of Alabama, Birmingham. I enjoyed the presentation, and Dr. McNamara, I'm going to keep picking on you. It seems like you're the guy that gets
last,
everything.
That happens,
I think we have a real problem in the nutrition field, and that problem is that what people tell us they eat has no relationship to what they actually eat. So we're dealing with data, and we're manipulating that data, and we're showing changes in that data, but I'm not at all convinced that relates to actually what people are really eating. Now, Dr. Brennan, I think you're on the right track with the biomarkers, but we're still a long way from being able to do that with the entire diet. So I think this is a real problem, and people always say, well, we don't have anything better. That's not an excuse to use a bad method. So I'm very concerned about that, and I think it relates to you, and you're probably doing it because that's the best available. But I think as a field, it's a big problem to solve. We've got to do a better job at figuring out what people are really eating.
I kind of agree in one sense, and in another sense I'm going to disagree. But there were lots of talks this morning about exotic technologies on your tooth that can detect what you're eating and all of that. And you're about to tell us all about them again. No. But at the same time, nutrition doesn't have to be accurate down to the 0th decimal place either. It needs to be reasonably accurate, especially when you're dealing with large macronutrients. So I think the data is very useful that we already have. Whether it's perfect, I wouldn't claim it is, but you can get a lot of power out of that data and a lot of useful analysis. So I wouldn't be too negative on using the existing food consumption data sets. Made my career on it, so so it's been very important. But no, a model is only as good as a model is. Like, a food consumption data is meant to represent 300 million people in America. It's got 6,000 people sampled. It's not perfect, but it gives you a good starting or baseline to start your analysis from.
Yeah, and I would agree with Cronin. I don't think our data is complete rubbish from a dietary data point of view. It depends on what you want to do with it, and I think we need to maybe not expect that we're going to have a complete revolution in how we assess people's dietary intake in the next few years, but we can make steps towards improving the accuracy of it, and I think that's where we need to go.
Thank you very much. Just to give someone else a chance, I did have a question for you actually as well, Conan, but I thought I would ask Gregory to tell us a bit more, well, tell me a bit more about the packet randomization. I wasn't quite sure how that worked, other than simply adjusting for confounders.
So I apologize. When I was practicing this talk, someone also raised this issue of, you know, Greg, sometimes when you give this talk, packet randomized experiments seem to raise a lot of questions. How about you show an example first and see how that turns out? So it's, well, we see how that turned out. So the difference is that, let's say you...
Maybe I...
Right. So if you were to randomize individuals to a city, let's say, we'll stick with the example, if you're interested in the effect of altitude on obesity, and you suspect that living at a higher altitude leads to lower obesity, well, you probably just couldn't randomize someone to a higher altitude or a lower altitude. Yeah. You would have to randomize them to cities at a higher altitude or a lower altitude. So let's say a soldier lucks out and gets randomized to Denver, Colorado. Very high altitude, but also has nice access to lots of skiing facilities, hiking in the Rocky Mountains. And so it's not the altitude per se that affects their BMI. It's all the other things about that packet that affects their BMI.
Well, I get that. And in traditional epidemiology, you just simply adjust for other factors.
So the difference is the ability to randomize individuals to that packet. Through the process of randomization, those subject level characteristics are going to be independent of altitude. So there's no selection of the soldiers into Denver, Colorado in terms of choosing it. However, so we can control for both observed confounders, like you might do in a regression model, as well as unobserved confounders, thanks to randomization, making those independent, those subject level characteristics independent of that treatment, which is altitude. However, you could not control for, randomization doesn't control for those packet characteristics. So you could additionally adjust for those characteristics like the average level of income, which is what's done in multi-level models. And in fact, multi-level models will, if you're looking at neighborhood effects, will make the assumption that there's not some other confounder in there. So packet randomized experiments are kind of like the ideal representation of what multi-level models should look like.
Can I ask my other question about predictive modeling? So that's a very interesting field as well, which hasn't been done that much, I think. Have you been able to validate the outcomes of your predicted models in any way?
It's a good question. And predictive modeling, you know, usually you think about predictive means about the future, and predictions are always hard, especially when they're about the future. There's a joke by somebody, wasn't it? Can't remember who, but it's not always about the future. It's also about just trying to understand the present. So even though, say, someone deals a card face down, you're trying to predict that card. It's not the future, it's the past. You're trying to, you know, and it's the same way you're trying to predict people's nutritional profiles or a population's nutritional profiles. It means you're trying to use data without them being able to tell you exactly what it is. You're trying to predict that distribution. So, in terms of validation, we have looked at some duplicate diet studies and things like that to try to validate these predictive models for chemical exposure. And the kind of principle we used way back in the Monte Carlo project when we did that was that we didn't want to underestimate the exposure. If we overestimated it, that was okay. If we underestimated it, it was not okay, because it's a hazard and you don't want to underestimate that. And that reminded me of your, was it yours who looked at the Fitbits in the talk earlier?
I did present some stuff on.
Yeah, well, there was some information on the kind of accuracy of Fitbits and the energy. Oh no, sorry, it was another gentleman, in the same session, and they had this very expensive calibration chamber, and it turned out the Fitbits were pretty darn good, in my estimation, in terms of the cost of a Fitbit versus this multi-million-dollar calibration chamber, and they're actually coming out pretty darn close. And I'm thinking they're getting better every year, and that was done 4 or 5 years ago. So,
well, they were in the calorimeter, but they weren't in the free living situation, I think. And that was
Possibly,
I mean, they were okay, but
Yeah,
same as everything.
they were seeming pretty good. So I've lost my train of thought, but the validation of those Fitbits, I'm sure, was, oh yeah, the key thing was they're tending to underestimate the energy, which is a good thing, because if you're trying to use it to manage your diet in terms of health and maybe lose weight, as long as it's not overestimating and giving you that license to eat the extra bag of chips, it's actually good, because they're underestimating. And maybe they actually did that on purpose in the design of those Fitbits.
Some of the apps did overestimate intake, though. Yeah.
Okay. Some of them did, yeah, but most of them seem to come out underestimating. So that was the same principle we used, not to underestimate the risk in our model validations. That's where I was trying to get to.
Chorsan?
Yeah, Chorsan Ku, ILSI North America. I have a question for Dr. Hayes. You talk about toxicity prediction in mixtures. And one of the challenges we have in nutrition is trying to look at meals and diets. So will there come a day when you would actually predict what will be the toxicity or adversity of a total diet?
I think the simple answer is one day, but not right now.
Well, any additional questions? Well, if not, please join me in showing appreciation for all of the speakers.